All right, welcome. Hello, everyone. So, today, as the title says, it will be a pretty quick and practical session. Practical meaning that we are going to touch a lot of arguments, a lot of details and technologies, and of course, we won't have enough time to go through them deeply. So the idea is to give you something reproducible that you can play with and start to look at how things working, and then step by step you can get more into that also together in the episode, in the next episode. So today, just bear with me, try to follow all the instructions. I have a repository that I will share in a second, so you will have all the recipe there. But the idea is to really get started and having something practical to touch. The main point will be installing a JupyterHub and the MLFlow server. So these are the arguments. How we are going to do is in the most practical way possible. So I'm going from scratch, installing and using the recipe that I shared with you. So cool. Now, I just want to, as always, give a little of time for whoever is joining and want to drop a comment or say hi. And meanwhile, I've put into the chat, so you will have as a reference, the repository that we are going to use today. It will also contain all the instruction and the recipes that we are doing and we are consuming in the next the next time. So yeah, let's see. I don't know if you can even hear me. I hope so. And yeah, I see my message, so it should be good. I give you just a bit of time to jump in. Right. Okay. So probably it's too early. Let's see. All right. No comments. So why not to immediately start with, all right. So just a second, I put a bit of music on, not too much. Maybe, okay, this should be fine. All right, sorry. I just shouted in the mic. And this is the repository I share with you. I'm going to document, physicists don't love to document stuff, so bear with me. And all right, so we are going to do the following. We use the folder that is called MLFlow and JupyterHub, and we will have a Kubernetes cluster for Jupyter, so meaning we are going to launch, as I did last time, a Kubernetes cluster. So here it is, 3 nodes, JHub is going to be called, 3 node small. Our friendly sivo.com will do all we need. 80 and 4043 open. Okay, everything is open. And then we need to disable traffic. Honestly, I prefer Nginx, although it has some extra cost, and Cert Manager. So this will be needed later on, when we are going to expose our endpoints. And okay, so Cert Manager, Metric Server, and Nginx. So as soon as you have questions or you want to know more, just drop a message. Don't worry, I'm taking a look. And yeah, so we need a Kubernetes cluster, and we are going to create one. Then we need, I'm pre-creating this, so while they are loading, I can explain you the plan with at the whiteboard. So Kubernetes cluster is starting. Then we need an instance, can be pretty small, medium maybe. Okay, user civil, public create, choose firewall. I think we can go with the default SS key, my SS key, and create this image. All right, so the plan is the following. We are going to build a platform. This was already well known by you and by the title of this episode, so nothing new. But the plan, if you remember last time, was about implementing an infrastructure that span on virtual nodes that can be an extension of a Kubernetes cluster that you have. So you can expand your cluster on supercomputers, on GPU providers, and whatsoever. So this have been demonstrated last time. We are going also to look at this further next month probably. And then you want to make it useful. And how you can make it useful? Well, simple, like installing data science frameworks. So I made a selection for you, and we are going to be very practical, as I mentioned already. So a recipe to install a baseline for 90% of the use case that a data scientist is facing day to day, or a generative AI engineer, let's say, like call it in this way, can face day to day. So for the machine learning part, today we are going to talk about 1 and 2 in this whiteboard. So we are going to install a JupyterHub and an MLFlow tracking server. The cool thing about 1 and 2 is the setup that we are going to do is like this. So we have a Kubernetes cluster where we are going to install a JupyterHub. All right, this will be the entry point for the user. I don't know if I have an icon for the user. I should. Let me find it. Here it is. We have our friendly user here, and that is accessing our JupyterHub instance. The JupyterHub instance is the entry point for making the session where the user is going to work interactively. So it will spawn on a physical node. Okay, it will spawn a container that is running notebooks, right? So data science, usually you prototype stuff in notebooks. So this is the assumption, a strong one, I can agree, but it works pretty well so far in many use cases that I found. So, and this will be a container executed somewhere. Now it can be the node where you run these things, can be a physical node, or can be even a virtual node, so running on a supercomputer. But let's just ignore this for time being. Then we have, okay, you have your JupyterLab, you can do all your work, you can do your plots, your data science magic here. But then you have immediately, and when I say immediately, a problem, because you run interactively and you do a lot of trial and errors. And what you really want to be able to do is store your plot, your artifact, if you want, somewhere. And you don't wanna just create an artifact, you want also to have different versions. So you want to save version 1, version 2, and being able also to make comparison between the two. And this is where MLFlow is going to enter in this picture. So we are going to have an MLFlow server, and here we need also a storage that will be a mean IO object storage. Don't worry, we are going to install this like a flick of a finger. And all right, so mean IO, MLFlow, and this will be our interface for both users that want to compare their experiments, and also for the code that will be able to automatically load store different version of your results into this system. So what is MLFlow, first of all? So if you look at Google, you will find out pretty easily what is the correct description of this entity. So it consists in many modules, first of all, and it is a software capable of making one big thing that is the one that we are going to use: tracking. So MLFlow tracking provides both an API and UI dedicated to logging of parameters, code versions, metrics, and artifacts during the ML process. What does this mean? Well, voila, we are going to look at a real use case. Just let me get the password here. I forgot. Just a second. Yeah. Okay. So in the password is this one. So our experiments are managed by MLFlow. So here you have different experiments, so different work that you want to save, and then you have all different sub version of your experiment. And for instance, you want to train your machine learning model, you can store all the experiments that you do with different parameters, and also having metrics shown dynamically as you collect them. So you can collect different kind of metrics, and everything's done with few lines of code where you store your model. You also have an artifact collection where you store your models, your parameters, and you can reuse these artifacts to make inference of your machine learning model. This is the cool thing of MLFlow. So this artifact will be stored in an object storage in our use case. But yeah, main point is we are going to create this MLFlow instance like you see here. We are going to reproduce step by step following the instructions that we put into the repository. And the repository, by the way, I posted into the chat, so you can find it there. Let me just check one thing, then we can go ahead. Meanwhile, if you have any question, please don't hesitate, drop them into the chat. And maybe I can also show the chat here, so you can, yeah. If you have any question, you can see it there. All right. Cool, so let's get started. And yeah, sorry, okay. Let's get back to our business. MLFlow, we're going to install that. There is a lot of instruction here, and how to use it, we're going to install it via an MLFlow Docker Compose. So don't worry, you don't need to understand what is Docker Compose. Here you have all the instructions that we are going to need, one after the other. We are going to install Docker with the script. We're going to install Homebrew. I don't know if we really need it, but okay. And then we have a Docker Compose to apply it to build. Now our machine should be ready. So we are going to, maybe one thing I missed before, these components here are going to be host on the VM we set up in Civil. So we have a VM and a Kubernetes cluster. Okay, so let's log in into the virtual machine. That should be as simple as SSH Civil and the IP. All right. Do we have Git? Yes. So we have Git, so we can download the Cygex playground. We clone it. Git clone. Perfect. Then we have, let me just check. Okay, sorry, I thought there was a message, but it's not. Sorry about that. Okay, let's go into Cygex playground. Oops. Okay, and now you can see that here there is JHub MLFlow combo, and we can log in into that. So cd JHub combo and MLFlow. So we stop at the first MLFlow. Cool. So now in here we have a lot of these different files. And the first one that we are going to look at is the fundamental one. But just after making executable the get docker and install it. Okay. So we are going to install Docker first of all, and then we are ready to go because we need Docker Compose to bring up all the stuff. Okay. Okay. Will take some little time. Okay. So we done it. Docker run won't work because Docker PS, sorry. Yeah. Sudo Docker PS is working perfectly. Then we need, okay. So we are ready. We open docker compose.yaml and there are many components. I just go very quickly. You just need to know what's going on, not all the details. So this one is the database. MLFlow uses a database to store all the meta information. Then the MLFlow server is also running, and we will build the image as we go. I make you We'll take a look at the Docker file in a second. And we need to decide an access key for the min.io server. That can be admin and then whatever set of passwords, an access key. That can be whatever. Test SciGex. And we are going also to say, look, I want to use a Sivo endpoint for this. Okay, we don't need to expose that. Ignore TLS. And we can do we have, we need a DNS for this machine. Okay, reverse DNS. Sivo MLFlow. Okay. So let me just a second now. Okay, networking. We need to attach. Well, it's not really a requirement for this kind of setup, but it's nice to have. Exactly. So we have load balancers. Okay, let's forget about, oh, here it is. Right, so exactly, this is the name of the instance. And if I remember correctly, there is a DNS made by, yeah, that is sivo.com. So if I do come on. So just a second. What I'm going to do, what I'm doing is I need the DNS name to connect to the endpoint. And this is going to be like that, if I remember correctly. Let me check. So let me check if it's resolving. Oops. The DNS name. No. Ah, it's not resolving. Okay. Don't panic. We still can use the private IP. So yeah, we're going to hide the Kubernetes cluster some way, and we're going to do this vim docker compose. So if you have a DNS name associated to your VM, you can do even easier with the messages and with the recipe that I sent you. But if you cannot, don't worry, we can work around that. So we can, for instance, do this. HTTP and then we put the IP of our machine. So at this point can be this one and port 9000. So all right. Then the other thing we need to do is to set the password to reset the password because forgotten. Yeah, I know. Again, I'm a physicist, so don't be mad at me. This will be our admin test 1, 2, 3. MLFlow server. Admin test me player S3. Perfect. Okay. So this is all good from the MLFlow part. For here we need to put all the same password we put above. Mini server URL. It will be 9000. Yeah. So in this current implementation, Min.io doesn't need to have any of this. We need just to expose the port. Here I adjust, my mind went blank, and we see Docker compose ports. All right, ports. Okay, yeah, ports, and we need 9000. Cool. So Mini is set up. Traffic will be the one responsible to expose our service, to expose our MLFlow service. So here everything is good. We need one final step before trying it out. That is the basic out in ini in the configuration in the repository I sent you before. In the chat you can find that. And that is the admin and username for accessing the MLFlow server. So I will put here admin and then a password that hopefully you won't discover. Oops. I'll put it in here. Just a second. Admin and then here. Oops. Okay. So done. Now we can go back. Here and trying the magic. So just to be clear, we start from a scratch machine, we install Docker, we filled up some Docker Compose details. In my case, I didn't have an obvious DNS name for my machine, so I had to remove all the details. But in your case, if you have a machine that has a wildcard DNS, everything will work pretty well out of the box, just filling out all the details. And yeah, so here and there, and inside the MLFlow there is the Docker file that we are going to use. So MLFlow Docker file. Yeah, you see that there is nothing special. There is Python 3.8, Slim Buster, pip install, and blah 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 blah. Cool. Let's give it a try. Sudo docker compose app -d or app directly. Let's see. Okay, now we are pulling the images and building all the images. Meanwhile, I just want to check that here we have opened networking, the port 9000 and so default. No, we need to create a new firewall and call it MLFlow. Okay, and we're going to open some ports. This is for foreseeable. You can implement this in whatever infrastructure as a service you have. So, but okay, the main point is that the port 443, 80, and so 80. Okay, 443 and 9000 should be opened to allow for the creation of the certificate for the Kubernetes, for the MLFlow server and the min.io port. Cool. So let's get back to okay, configuration received. The routers. Oops. We need to change this host name, of course. And yeah. The absence of the DNS name for the machine, I don't think it's supposed to be like this. Ooh, let me check. So default. Help. All right. Yeah, no. I was honestly hoping for having some no. No. Yeah, I gave it a try on a different machine before, but now I cannot find. Name test the Changot. Let me check if I can do that. Okay. Well, okay, look. I think we are going this way. Right? So we saw this, so we go to this machine and we see what it should happen in reality if we add a DNS name for our machine. And hopefully next time I'll be able to show you this on also on Sivo Cloud. So okay. Perfect. So you can see there is the very same repository in here, and Docker PS, there are the very same containers. An MLflow server, MLflow DB, Compose min.io, and traffic. So the very cool thing of this stuff, and next time we will be guided through the use of the MLflow and virtual kubelets all together by a CERN researcher that is doing this in the context of Intertwin, and that accepted to show us how having an external entry point for your tracking of your experiments is very useful also whenever you go run on external resources. So whenever this red node is not a real node, is a virtual node, just like we did last time. So a job that is running into Slurm. So we have MLflow tracking experiments. I let you the reference there for MLflow. I'll take a note for one small thing that is actually providing guide also for known load balanced machines. So a very basic, more basic than this setup. And then we need to go and to see the JupyterHub. So any questions so far? I know I went pretty fast and something didn't work, so it can be quite confusing. Feel free also to say that on the chat. I just want to be sure to conclude everything in time so we can talk with Matteo. Is the person, the CERN researcher that is going to showcase how they use MLflow for their tracking of their activities. And before going to the JupyterHub, I just want to set back and understand where we are. We set up an external entry point where we can contact through a set of APIs. So if we go here in tracking, you can see that you have a very useful quick start instruction in the MLflow documentation, where you can learn how to log your parameters, metrics, how to use all the stuff to load and play with the MLflow UI. So here again, you see the very step-by-step example that we are going also to look at in the example that Matteo will show next time. So here you go. You should just import the MLflow library and everything should be ready to track and to send information to the external endpoint, that in our case is this one. All right, so we have MLflow set. We want to have an interactive way to producing this kind of example here. So everything is Python, so it's pretty useful to have a JupyterHub instance. So we can spawn a Jupyter lab with MLflow installed probably, and being able to execute all the stuff. Cool. So, all right. JupyterHub. So it will be, just take the dashboard again, it will be our hub in here that is responsible to authenticate the user and make a spawn of a lab instance. Hub lab is quite tricky, but yeah, it should be clear that the hub is the one responsible for authenticating and delegating the execution on a container with the notebooks and with all the browser instance of the Jupyter Lab into a separate node. So this will be eventually a pod in a Kubernetes cluster, and also JupyterHub will be a pod, but it's more a web server responsible to make communication works between all the parties. All right. So the tricky part is that JupyterHub works great with Kubernetes, and so we have this. JupyterHub is installable to Kubernetes with some requirements and using Helm, right? Helm, we are going to have dedicated episodes to how you package software and applications for Kubernetes. So one of the most adopted way to install packages on Kubernetes, if you want the package manager of choice for Kubernetes, is usually, so far, Helm. It's not the only one, is the most adopted so far. So you need to have Helm installed, and you also have to have access to a Kubernetes cluster. So to do that, we take a stab at Kubernetes clusters, and now should be up and running. We click here, and we take load balancer is fine. We take the kubeconfig. Okay, kubeconfig, you download, you have your Kubernetes cluster available, meaning that if now I let MLFlow running aside, I can do export kubeconfig. Come on, okay. Kubeconfig, and then downloads Civo JUb kubeconfig. Okay, get node, and voila. So we have 3 nodes working. We have also Helm available on my laptop, so the client is running. You don't need anything else, just the client is fine. And Helm works in this way, in very few words. You have a configuration file with which you can customize what you do. So customize the normal instance, and the normal instance of the JupyterHub Helm chart can be found in the documentation. So if we go back to the documentation part, you have setting up with Helm, installation, okay, set up JupyterHub. As they mentioned, the step 0 there doesn't require any custom configuration on your side, so you can keep a config.yaml empty. That is the one that we have here. And then you can go ahead with these simple commands, right? So I'm just executing the guide. So installing the repository, the chart repository, and we're going to do something like this. So config.yaml should be named japp-config.yaml. Chart version, probably we don't need to set it. It should take the last one. Create namespace will create a Kubernetes namespace that we say here. So we call this jhub, and then the name of the release. So the name of the package that we want to show when we do an ls of all the instance installed. And we can call this jhub as well. So now this should start. And eventually we'll finish. So you see here all the detail, and we will see that these two pods are running. These are the core of the hub instance. And all right. So here, what we can do to try this right away. So you can start with this, forwarding the service to our localhost. And if we go in here, we see service unavailable still. So just 1 second, let's take our get pod -n jhub, probably it's still, yeah, downloading, pending. All right, so just wait for the Kubernetes, the hub pod to finish. And we have a very basic setup to get started the next time. So next time we will adapt the JupyterHub instance that we have here, this plain installation. It will get more serious, so we will install all the required part to be able to offload your lab to a remote host. And then we are also going to make this remote part a Jupyter Lab example that is talking to the MLFlow server. So, okay, I hope this will eventually go running. It should go pretty soon. Let's see if everything is working properly. Describe pod hub. Okay. Get. It will take a while on Sivo to get. Yeah. Now it should be ready, I think. 84, yeah. Exactly. So now the persistent volume claim, we'll have a dedicated video on this as well. So all these mechanics are pretty complicated, so I just leave you with the bare minimum information to get started. So you have instruction for, just let me send here in the chat the references that we took. So this is the bare minimum installation for JupyterHub. We are going to see how to configure this next time. To customize, not to configure, sorry. This next time. And also, yeah, the repository with the Docker Compose for MLFlow you have also on the chat. So we should be good. Okay, so now the proxy should work. Exactly. And here we go. So localhost 8080. Perfect. I don't know. Okay. So we use the default password to start up our server, and you see that the experience under the hood, what is going on is the following. So if we do the export again and get pod jhub, you see now that there is a Jupyter with the admin that is pending, and I would say that it's creating a persistent volume claim also that, so we need some to be patient to get it started. Let's check. Yeah, exactly. So get get PVC. Okay, bound. So these are all the volumes that by default are mounted by JupyterHub, allowing you to find your work in a persistent way after you close your session. So now this is working, and also, yeah, my pod is in initialize. You see, say, okay, the volume is not ready. Just wait a little bit. So pod is ready. Notebook is coming up, and we are ready. So lab now is magically loading, and we are done. We are done, so we can test right away this. Pip install sklearn and MLFlow. Oops. Sorry. Okay, minus user. Come on. Scikit-learn. Sorry. So scikit-learn. All right. So we're going to install this, and quite noticeably, okay. So it's installing all the useful stuff that you need. Also pandas we need. You see the admin now is running, so everything is under control. All right, installed. Now we can pip3 install pandas. That's the other thing that we need. Okay, and then, yeah, I know. If I restart the kernel, this time should work. Exactly. Good. So we can try directly our MLFlow stuff from JupyterLab. So you can look by yourself how useful can be this kind of solution. So this is the endpoint of our set, and if I remember correctly, this should work. So let me take again this. this intertween and okay. Okay, I have done. We are connected. And this is a simple example. It's a iris dataset with train and split and logistic regression. So normal data science stuff. And okay, so we can just copy and paste this into a this into a cell. It will load. Okay, loaded. We create an MLFlow quick start experiment, and we will see immediately appearing in here a new experiments. See, MLFlow quick start. This is now our experiment, and then we can start a run and log metrics to our remote server, meaning, oops, sorry, mistyped, meaning that we can tell, okay, we have these parents that we use for the regression above, take them and create a model based on this and log all the procedure for the model training. And as you can see, now it's running, and magically here we should have now exactly our experiment with all the parameters that we set there, and model metrics. Again, the accuracy should appear, and metrics, we have no system metrics, and we have the model, the regression stored here. So pretty impressive. You can, with this simple setup, a machine plus a Kubernetes cluster, you can have a pretty powerful tool for doing your data science and organize your artifact. So I think that's all for today, and we will restart from here. We are going to look at how to configure JupyterHub to spawn stuff on virtual nodes, and we are going to also see how you can track your experiment whenever you go and run on a supercomputer via the virtual kubelet that we used last time. So the idea is basically, just to conclude, the idea is to basically take what we did last time, what we are doing right now, and what we did today, to put them together in order to have a working first baseline for doing your data analysis and your data science or modeling your machine learning pipelines into something that is usable already. So JupyterHub and MLFlow, it's one part. Then we have the pipeline management, that is the kubeflow part. And we will have also an example of Helix ML for generative AI systems. So this will come later. And the next time we will talk with an expert, so with a researcher from CERN, that will explain us how in the intertween project context we did this and how can be extended to generic use cases. So I'm concluding asking for any questions, or if you want to say hi in the chat. Otherwise we are close to the 1 hour that we planned, so I think it's a good time to close the loop. Okay then. Okay then. Thank you a lot for following up, and if you have any curiosity, you have also the repository, my social contact. You can drop a message, and I'm happy to answer. So thank you, and hope to see you next time with the live that we have in mind. Yeah.